Alrighty, good afternoon, everyone. Being here, we're going to go ahead and start with our first presentation, and it's going to be Josh Eaton from Woods Hole Oceanographic Institution. Would you like to make no?
I think I should be okay, as long as okay online. Dennis?
Some of the participants are.
Bring this chair around so
Okay. Uh,
Can you hear us, Amy?
Amy, can you hear us?
You're muted.
We can hear you.
Fantastic. Let me know if you at some point. I'm going to start off by saying thanks for coming. Really appreciate it. I'm sorry we don't have more chairs. For whatever reason, they gave me a small room. I really think that they would have learned by now that my presentations are usually that everyone comes to when they don't know what else to go to. And at least it's amusing. I'd also, next up, I'd like to introduce the Joshua Forum 2.0. Actually, it's 3.0. Sorry. For those not in the know, I do wear the same outfit every day. Not the same outfit. So we made progress. All right, so over the last couple of years, I've been working on a transducer elevator for the research vessel Armstrong. All right, so the purpose of that elevator is for low impact transducer installations and swaps, and along with being an adaptable platform. With the goals being that it's going to fit in the space. It was super critical, and you'll see in the pictures that I had about this much space. To be inexpensive. 50-50 on that one. So for the design, our constraints were really around the space. We were very height limited, and I obviously can't change anything about the valve or the structure of the ship or how high it is. They wouldn't let me flame torch a hole above where that valve is so we could go higher. I don't know why. The next thing was it has to be able to be installed, which is, well, I guess important to have it be installed. And again, it was a very challenging thing to do. And the last factor was the valve that we had to install it on, which was a 20-inch gate valve, giant thing, bottom of the ship, terrifying to open up. And if you see Emily Chung walk around, she has a t-shirt on that says, "What's the worst that could happen? The boat sinks." This was actually that project. So we went through a couple of different iterations on the design, and it turned out this first one, which is the one part of it I liked the best. The box was the easiest way to get transducers in and out. We needed the least height. However, again, installation parameters, we couldn't get it down to the transducer room. And I had, turns out, about a 20 by 20 inch square that everything had to be able to fit through. Either that or the ship had to come out of the water and we had to come up through one of the larger transducer holes, and everyone was like, "You can't do that, Josh." So our final design ended up being a fairly robust, fairly simple system. But however, when they first look at it, they don't understand how can you get a transducer in there. You just have a cylinder and a lid, and you have a piston that goes up and down. There's no way to open it. We'll get to that. So the process that I took was obviously an engineer. So first was design, build it, but the interesting parts of getting the components, testing them, testing the assembly, and then testing the entire system. Let's see if this, yeah, so this is going to shoot through all my pictures, and we have a whole bunch of neat things going on. Maybe I made this go too fast. All right, so eventually I found that I didn't have enough room as I initially designed it and testing it on the floor. Coming around to testing the servo motors that we had, and they work pretty well. And you can see that they, which is the important part for, well, and had some problems with that later on in the test as we were building things. And eventually, yeah, so we had it on the stand. There were a couple of times where I changed parameters in the servo drives, but we had to take away the S because I only changed it in one of the drives and hit the button, shot screw heads across our shop. So that was exciting. But yeah, when goes up and down, which is exactly what you want it to do. The next one is going to show us how it opens. So this part is kind of neat. So on the side, there are 4 locks that go into a cage. And so the elevator then lifts itself up off of itself. And those 4 points of contact are quite rigid, so we don't have any movement. And then, of course, I had to test it with the transducer installed, and my worst fear to light, we could actually move with the transducer installed because I was surprised at how heavy they are. So next up, these are probably going to go by fast too, and so I'm sorry. So our installation, you can see there's the large valve, and this valve hadn't been opened, so we had to clean it off. And here's the space that we had to work in, which was not that great. Managed to get everything over and in place and assembled. And then came the testing. This part I was not prepared for, that the ship was going to want to test everything and had to hold pressure for 24 hours. I was like, let's go, let's move on to this. So we tested with air, then water. We used a dye in the water just to see if we saw any leaks. And the answer was, no, we didn't see any leaks. Everything's great. And then we tried a crack the valve test, and we let that sit overnight. So like 3 days of me doing nothing. And I'm like, I want to get more done. And eventually we did get to the point where everything was assembled, and you can see the elevator is fully deployed. On the left-hand side, you can see that the top and here, top is up. So that's kind of the brief overview of our installation. Now, I didn't get a lot of pictures after this point because I was the person running the controls. And so we had some unreliable encoder communication, which was troublesome for the servos. For those who might not know, a servo motor is just that has position feedback on it. So it's not a servo if it doesn't have that on it, and then it doesn't know where it is, which is a large problem for a system like this. We started to get that straightened out, and then we ran into an issue where I was up being a keyboard warrior, and she touched system and she got a shot. She said, Josh, did you ground the system? She's like, grounded the system. I mean, we are on a ship, so there's no ground, but that's a discussion for another day. But it turned out the electricians on the ship didn't connect the ground or it came loose. I'm not going to cast any blame. So it turned out that that was a lot of our problems, was that we were running ungrounded. And so we were getting a lot of noise where we shouldn't have been getting noise. And then we started getting overloads. So these three things together, we ended up damaging a couple of the motors, the original motors. The brakes weren't then turning off. Then we were trying to haul against the brake, and that doesn't work. We did get that all straightened out, and this is where I got to sit. Yeah, acrophobia, claustrophobia, all in one. So in operation, I was hoping Emily was going to be here so she could give some feedback on it, but it has been from July to this September, testing a pin on the data. I didn't actually care about the sensors that were going on it. I just wanted to make the sensor go up and down. There's some other people to ask about that. Some of the weaknesses of the system were, there aren't any. No, I'm kidding. I'm blanking on what I wanted to say here. It's not as easy to reconfigure the position as I wanted it to be. So again, version 1.0, I don't have a user interface on it. I have a couple of buttons that say go down and go up. And then you can switch it to manual go down and manual go up. And so those buttons, actually the automatic modes, will bring you down to the exact same spot that you went to every time. You can say go up, go home. It goes all the way up, and you can put those locks in, system secured, or you can hit the deploy button and it goes down the same spot every time. Strengths, yes.
Do you have any kind of lockout on the valves so that they can't be operated when the valves closed?
Brings us back to what was it, 0.2 in be cheap? No, be inexpensive. And so that was not in the original proposal, but that I want to include. And I think that comes up. I think I have something about that. So yeah, that's what I said. And we just removed it just before I flew out. Took about half a day to do the removal. Didn't have to pressurize the space we were in. It was quite easy. Yeah, everything came out pretty good. So for the future is to make it user configurable. I think it should have a little screen that you can say this sensor amount of tall or X tall, and I want it to stick 2 inches. I want it to be recessed 2 inch, whatever it happens to be. And that should just be something you shouldn't have to call me, and I shouldn't have to go into the PLC program and say, nope, we're really going here. The next thing would be a universal cable run. So I found a gland that I could fit the deck cable connector through, which was great because no one wanted to disconnect it. We didn't have to cut the cable. The downside of that, we had to pull through however 100 feet through the whole thing because we couldn't go the easy way. So we want to put in a universal cable run that brings you from the transducer room up to the server rack to the whatever they call them. I can't remember. And then the last thing would be a motor for the valve itself, because they're very fine pitch and watching them. Because I'm an engineer, I work. I kid. Uh, spinning the valve was terrible. And, it's like a day, you're just there turning. All right, it's not that bad, but having a motor on the valve would be useful. And then we could do the type of lockout. We'd know if the valve is open or closed. And it would certainly speed up the process to lower and or to deploy and retrieve the elevator each time. Yes,
They have to count the turns to
nope,
make sure that it was closed all the way.
nope, when it didn't turn anymore.
Well, I know, but sometimes they're old and they get stuck. And then you think that it's closed, but it's not.
There isn't a visual indicator on it
Oh,
that says where the travel
okay.
is.
That's a fancier model.
This valve, it leaks a little bit. So I'm happy that they did all the testing and made me do all of that and didn't let me take shortcuts. But it is a little disconcerting when we opened it up to take out the transducer and you see these bubbles coming up. Yeah, what? So hopefully they'll take care of that in the next shipyard. Any other questions, comments, concerns? Yes.
You have a valve for the air out. For the trans, so you don't get air.
That's another thing that will be implemented in version 2.0. I've been looking at automatic air burping systems, but we do have a valve up on top that can manually release air, any air that gets entrapped in it. And actually the way that we empty it is we actually plumb air into the top, crack the valve, push the water out, and that has worked relatively well.
What about how far below the hole was it going? Like what rating of like speed through your design all this for?
So it was designed to go flush to the hull, but probably my fault. There was a measurement that was missing in the drawings that I received from the ship. Whole long story, we were 2 inches short. So we didn't extend beyond the hull. Ideally, been 2 inches the other way, we would have been 2 inches below the hull. And there is a plan to remedy that if we do use the same transducer, we can attach an extension onto it, drop it further down below the hull. And at those minimal extensions, there are not any practical or there are not any design limitations, but there may be practical limitations from cavitation, Harman vortex shedding and the like, causing vibrations. But it is very stiff once assembled and deployed. Russ.
What sort of overhead? Minimum overhead clearance to install one of these.
Minimum overhead space would be, have to have basically the distance between the top of the valve and the hull of the ship, plus the transducer height,
yeah,
and anything assorted that goes in there as well. Some amount of rigid support. So that's that you saw the up on the top of it.
Do you know what the height is off the top of the valve flange?
I should know, I believe it is 106 inches.
Okay.
And that's 2 inches short
I think that'd be cool.
for the Armstrong.
And you said a 20-inch gate valve, is that because it's a pretty standard 19-inch spares well?
It's because that's what was there
Right.
and they didn't let me change it. So
Okay. So you already had a valve well there.
yes. So that valve, there's actually one has lower overhead clearance. So I'm glad they didn't give me that one.
Understand.
Anything else?
Was there any consideration to use maybe a telescoping hydraulic ram?
Yes. I don't like hydraulics. They're gross. I know that they'll work fine. I could have done it.
You're pretty confident in positioning and stuff though with what you
Yeah.
got, yeah.
Yeah, it's like. It's an absolute encoder on the back of the motors. And so it has something like over 500,000, maybe like 5 million points of resolution per turn. So we can get fairly accurate because one turn is about 3 inches of travel. So we have 5 million points within that 3 inches that we can hit.
And the thought was supporting scientists that come up with something and you're like, we don't want to come into dry dock. We're gonna
Yep.
go ahead and drop it in this way because we don't have centerboard or some other way to.
Right.
Yeah.
So, yeah, that was the idea, was that any inch, well, really. It was designed for transducers, but it probably could be any instrument.
Sure.
Could be put in there, plumbed in, and brought up.
And your repeatability confident enough to like put it behind an ice window or something and.
Yeah.
Yeah, sweet.
The Pinnacle, Jules won't give far more information than I can, but it was. And the data was just, it's basically a failure of a transducer.
One of the
from what I
beams,
understand.
one of the beams was bad.
Okay.
And
So-
it's gonna be, and as you said, you pulled it, this where it came up.
Yep. So it's being sent back to RDI. To hopefully have them figure out why one of the beams wasn't working. And I have to say, in my defense, the beam wasn't working before they let me touch it.
What are your thoughts on new builds incorporating something like that?
I think having a universal elevator would be a great idea, especially if get me to build it, it'll be fun. As far as the amount of use we expect to see from it, the Pinnacle was the catalyst. Because wanted to get that tested. And then we have another use coming up, which is a sound source that a scientist wants to put on. And I can't remember, Lubell sound source. Not that that means anything to me, so. Yes,
Would you think about accompanying that design with your own gate valve and cut a hole in the ship design? For additional sensors, like, because in that case, you already have a gate valve.
right,
But what about ships that may not
have
have that at the moment? Plus,
I would leave that up to the operator.
Because usually you
And
just have a well, right?
Yeah.
Yeah, exactly.
like on the cam, someone asked us if we had a fish, which we don't. We don't have any EK.
yeah,
And so seeing that gets me thinking, like, well, if they're well, which we don't, but
Toe body,
would you build one?
toe body. Because your EK is gonna be multiple bands.
I saw this a couple weeks ago. The total height from the outside shell to the top of it, which was very limited in almost every bit of.
I
the tank.
used there's 2 inches of clearance.
And it's quite high, maybe 10, 11 feet, maybe from the all outside to the.
Yep.
To you, so it's fairly tall. Pretty good space to mount it.
Would have been easier overhead because it was tight. Everything had to be just right as things in place and
It probably fit it right into Sally Ride.
Gee,
Yeah.
anything.
yeah, we've done this.
I mean, Sally Ride is both of those boats are outliers, that have the biggest transducer rooms that I've ever
Sure.
seen. But, I mean, that was still a pretty generous transducer space that you were working in. thing for fleet for you guys.
It's huge, there's a
Oh, yeah.
gym down there too.
Even for this installation, that was pretty roomy compared to some of the places I've had to work.
Actually, between the time that I installed it and then removed the transducer, the ship's engineers form around the valve. It's now lovely to work on. You're not like standing down on the deck trying to, it's much better.
No, you don't need to.
After we finish the hard part,
Yeah. We'll dress that thing up a little bit.
ice until you drop something, and since I drop, they don't let me work over the side anymore, so. And then you have to like try to get under, so to jump back to your question, I think that would be a feasible thing, but that would have to be looked at. You know. For the ship in question.
So if you've got the, the well's clear and science party shows up at the port call, what's a rough idea of how much your port call is and get that thing mounted and routed and stuff like that?
So. Are there any managers in here? Managers, cover your ears. It takes a day to install. It took us half a day to remove the pinnacle.
Okay.
And it would, at the same time, if we had the next sensor ready to go, we would have taken it out. Plop the cage on the next one, we would put it in, and we would have had it physically installed in half a day. And then with the cable runs, the programming offsets, still easily within a day.
Do you have room instead of using the gland for some of the smaller, more on the inside, so that you don't have to use the gland and run the 100 meters up there, just use a short adapter cable,
So,
kind of it.
I mean, it could certainly use an adapter. I mean, we're using like 1.5 inches, a quarter NPT, so that's like 1.75 inches. So it would certainly be possible to build a plug that then had the right thread for a connector to go into.
Depending on sea conditions, you could actually do this at sea.
I mean, I wouldn't want to, but you could.
You do a lot more harder things at sea than.
Anything else?
Thanks, Josh.
All right.
To get you.
All right. Hi, I'm Josh Eaton from the Woods Hole Oceanographic Institution. I'd like to give a presentation today on the East Coast Winch Pool Data Collection Program. I wrote this either for myself or for the technicians on the boat, depending on but the idea was to be able to have our winch data by the ships if they so desire. So this is kind of a tricky thing because it seems like every winch manufacturer has done their best to make it as difficult as possible and as different as possible from each other. I tried to minimize that earlier. I came up with points, and that hasn't been adopted. So I'm still pushing for it. When we buy winches, we get it in that format. But since everything is not in that format, I opted to create everything that we have isn't in that format. All right, so the why. Well, I started that already, and that was to access the data that our winches are producing. And hopefully makes Rick happy. That tension and payout is being monitored, recorded, and the like. Its goal was also to then process that data into taking it from that massive 20 hertz data stream that is useless, simplifying it down into the points of interest, which are for every cast, the maximum tension and the maximum payout. So after you run a cast, you can process it. Although if you're using the program cast, and it will keep track of those max and mins, and then it doesn't have to go through the processing process. And it was supposed to be easy to use, completely failed there, so sorry. So the building blocks of my program, C# built in .NET Core, uses the community MVVM toolkit for the MVVM helpers, along with using the cross-platform UI framework Avalonia, and it uses live charts for the real-time process. I know not everyone in all those little bits and details, but there's probably someone that is. If you have any questions on what any of those things are, I only half know because I'm a mechanical engineer, I'm not a programmer. Next up is the program structure. So I structured the program in the MVVM format, which happens to be model, view, view model, which segregates the parts of the program to make it easier to test and easier to maintain. And so the models basically contain your basic data structures, along with the views, which are what you look at. So that's the UI, along with the view models. That's where all the really important stuff goes. Was something I added because I wasn't too sure how else to do that part. So I have a couple of data formats that some of us might be familiar with. So this is the legacy format. No. And this is MTNW1, I believe, from they're now rugged controls, and it's output by all LCI 90Is. So that's one of the formats we're dealing with. From that, I came up with the UNull string that includes a little bit more detail. Close to having a tension event, or when we do have a tension event, so that we can look around that area sooner. So if we have one of the bits in the warning or the alarms, I can't remember what all 7 of them or all 8 of them are, but they would tell you something about what's going on with the wire, and you could then look back and look at the data around it if you needed more information. And then there's the Hobalt format, and I did not include it because it was really tough to get through. And every Hobalt, not every series of Hobalt Winch has a slightly different format. And so those are the main 3 that I've been dealing with. There's a few others. So now getting into the features. What can it do? Why would you use it? The biggest one, time plotting, that meets Appendix A at operator stations. It logs the data. So all of our winches can internally log the data, but if the ships want the data, you guys can log it yourselves. It can also provide a remote display. So if you wanted to add a display up in the bridge, et cetera, et cetera. And it can also provide conversion from one format to the other, maybe from a couple of formats to a couple of formats. I'm not 100% going from all different. So a lot of that is to bring in that portable winch data that's been normally left out on the deck into the lab, and allow that to be seen by whoever wants to see it. So I know that the Endeavor has used that quite a bit for a number of our winches and our doing casts on board, and it has been fairly successful with them. Like I said, it really makes it easy to get those cast log files where you can just pull out the max and min values, and it can add additional displays in other places. and convert TCP, UDP, serial feeds, all the like. So how do we use it? Well, first we open it up and we get this screen. The first thing that we have to do is we have to go to the Winch configuration screen and we have to enter in a bunch of parameters. This is the part where it's not as simple as I'd really like it to be. So we start out with the Winch itself. And if you've already made a configuration file and you click select Winch, that will load that particular winch's settings. You can then provide it a name. Then you need the IP address, port number, the type of communication, which is confusing. So for the East Coast Winch Pool winches, I found it was easier to get through our remote VPN servers with a TCP connection. However, the LCI 90Is want it not to be a server, they want it to be a client, which reverses the two, but it's harder to get through the firewall that way. And then Hobalt is UDP, and there's a few other UDPs as well. The next, you can choose a couple of different logging parameters. What you want to log. If you want to log the full speed data, that's the 20 hertz. It won't make up 20 hertz data. It will just record at whatever rate it's coming in at. So if it's 3 hertz, it'll record at 3 hertz. Then the log max data will set up the log file to log those maximum data points that I mentioned. And the next is to either use the winch time or the computer time. Time drifts, and it's a little bit easier to change the time on the computer so it will match ship time, as opposed to East Coast Winch Pool time, which may be different. The next thing, you can choose how long you want the chart to display for. Setting it up to the maximum 60 seconds, that's a lot of data points per winch. So 30 seconds I find is usually a pretty good window. And the speed, payout, and tension unit are just display parameters. So if this was something that I think the Falcor asked me about it. Those could be changed because apparently they don't use our standard system of meters per minute, meters, and then pounds. I don't know why. I know, right? And then you can put in your Appendix A parameters for your warning tension, your alarm tension, and your braking load. I don't know why I included the braking load in there because that's not used anywhere. The next thing is you can configure your output data. And so you can send the UDP data, send serial data, add or update winch will do the right thing, and remove winch removes the winch. And so when you finally get your winches in place, it does allow you, so if you use a lot of East Coast Winch Pool winches, you could set up each of our winches with their name and you assign them a permanent IP address, and you come on, plug it in, it'll be automatically populated in the list. And if you need to make changes, you can. You can then set it up to, and then record the data as needed. One thing that you can do is you can resize the amount of room. You can select how many winches you want, but that's going to be governed on how big your screen, well, how dense your pixels are, what your resolution is. 1 looks really good in my opinion. 2 looks okay. If I made my default text size too small, you can resize that area to get a little bit bigger text. The lab, you don't have to be sitting in front of it. And last thing, save location, and that's shown down here. There is help. I don't remember when I last, so this might be for a version previously. And then there's the CAS processing process, but that's really boring. And I pressed spacebar too quickly. If you're using the logging or the max log in the program, you don't really need this. This was more to process the log files produced in our winches. So it's kind of a more of a historical feature if the program's not being used, and I really only wanted to have one program and not two. But you can set what the minimum payout is to start a cast and end a cast, what the tension is to start a cast and end a cast. And we have Lynn just showed up in the back, and she can tell everyone how great this program is and how much she detests every time she has to use it.
Very useful, and one thing I like best is that you're so responsive to requests for change or edits. Also for sending out a signal via UDP to someone else on the ship.
And one thing that I need to test to see if we can send from this program to this program. Instead of trying to connect multiple computers to the winch, if we could set a single one of these up running in the lab, then you could broadcast it to as many stations as you needed. So that will be on my to-do list. Any other questions? Yes. Oh,
You
great.
have this so it fills out a running use log.
It does not automatically do that. So if you hit the log max button, it will log that cast, it will advance to the next cast and be ready, reset the maximum values.
You don't have it shifting over to an Excel file that does the running use log additionally.
No, I just keep track of what the maximum value is during a cast and then log that. Yes.
So this is a data acquisition system, so I understand that correctly?
Yep.
So who is using this data and how is it being used?
Great question, Rick.
It's telling us, and some of that format is very difficult to handle.
Yep.
We're looking at those maxes, max depth, max tensions, depth or depth at the time of max tension. And we then go back and look to see if the user is using the cable within their specified safe working load limits. Because we're concerned about that, particularly when we loan a cable to an outside user. I mean, the ships have got to use their own, but when we loan a cable, we want to make sure it's being used and properly. And then when we get a cable back, we will end for end it. And if there was a particular area where there might have been some high tensions that we're concerned about, that area might be a little more scrutinized.
So you're evaluating the wear or the life cycle of the cable itself?
Well, we're looking at it physically.
But it gives an indication of where to look.
Yes.
Okay.
One thing Rick and I have spoken both of RV Tech is knowing where the max tension occurs. And the second item is knowing if you know the total length, what's remaining on the drum that didn't get to a max load. So there's a couple of parameters you can calculate.
Well, I don't know how much is on the drum, but that is something that could be added in. More work, thank you.
Well, say for us.
Yep.
It's as a cable gets shorter and shorter, that reference point goes away.
Right.
That you're always using the wire out.
Yeah.
And so wire in or wire remaining on the drum is a better number for us, because now if you had some kind of a high tension, eventually that location of that high tension event may eventually go away.
Yeah.
And no longer necessarily a concern or a hawk or something wrong there. So it's a much better using the end that's on the drum as the reference point. I think, and I think Ted agrees and others, that that's a better for evaluation of the cable in the long run.
They get applause.
Yeah, I've got a couple of questions. First is, what kind of systems do you know this program to run on? As far as operating systems?
I know it runs on Windows.
Okay.
Because that's what I use. I was testing it in WSL, which is the Windows subsystem for Linux, I believe. Was able to get it to run there originally until I started using things that had conflicts. It doesn't replicate an entire system. And so I would need a Linux box to test that out. And nominally, it runs on Mac OS as well, but I don't believe anyone has ever tested that because I don't have a Mac and no one has ever told me otherwise. The project is on GitHub if you'd like to improve the code. Great, because it needs improvement. And there's also a feature that you can check for the latest version using the program. It doesn't automatically call home or anything, but it's just a click and it will tell you if you're running version 5.02, and I've now released 5.03, which is some minor thing that I updated.
Will it do a filtered average?
Filtered average. It currently does not.
So it's just for the raw 10 hertz?
The raw data at the moment. Yep.
One of the other parameters on appendix A, logging alarm events, those kind of things. And what should be associated with that is a good question.
It's a great question. And I am not there yet. So I am making progress to that, and it actually displays colored bars on the graphs for the tension warning and the tension alarm limit from appendix A. And since those values will be there, they can then be used to log when that happens.
Are any ships using it permanently, or is it just for the winch pool?
I don't know that anyone is using it permanently. I think Lumcon might be. The Falcor had been asking about it. I don't know their status on it. Anyone is free to use it, provide feedback. Take it over anymore. Anyone's choice. But it was started just to be able to get our data from the winch into the lab. Yep.
In January, there's going to be a A&D workshop in Woods Hole. And part of what I'm thinking about, Rick, and talking to Rick on, is what good is this 20 hertz beta or recorded time series? Anybody using it? How could they use it? What can we do to kind of standardize across the fleet? So if you have thoughts, talk to us.
You can get 20 hertz to do a display, that'd be awesome for dredging.
Totally. You get what?
You can get 20 hertz data refresh into a display rather than just logging, then
Yeah.
dredging people would
No,
love
no, it does that.
it. Does
It graphs in real time
at 20 hertz.
at 20 hertz. Well, at the data rate that it comes in, assuming that your computer has enough processing power to handle 20 hertz data coming in and everything else, it will do that. If you try to run it on my old 486, it will not.
Yeah, deep sediment people would.
Is it okay if we take a short break and then we'll start again in 2? If people want to have more questions, if they don't want to stop.
Anybody online?
Yeah. Nothing in the chat. Nothing in the QA. Now, I'm sorry, I really wanted to give an example of this running. But I forgot to call home and ask Jamie to leave a winch on tonight, so I could have dialed in. But we could have had real live data from the East Coast winch pool if I'd remembered, so I apologize.
Oh,
Yep.
How long would you store data? Like, so you're saying that you've got data on these winches, it stores them internally, how long will you keep that around for? After you get a winch back,
We
or do you not?
tend to process it, take it off the winch, send it over to Rick.
Oh, you do, okay, great.
So it travels with the strength member, right?
Yeah.
Yeah.
So the winch pool doesn't have spring, we get them from the wire pool.
Yeah.
They're concerned about the health of the wires, Josh has developed this to provide Rick with information on how the wire was treated. Set the door to a science user, or you guys have more experience with science users than I do, but the wire has come back with 100 meters cut off the end and they didn't say move. So this is, you're getting as much information as you can from the winches themselves, and then there's usually some other information it'd be nice to have.
Yeah, I didn't even know that you had any logging in your winch until after it's gone. There's nothing in the manuals talking about that.
It's,
But
and it's not easy to get to in the winch either.
yeah, because I opened up the penetrations and took this one spare LCI out. And put that into a scientist's computer that couldn't log but could display. But I didn't realize that your VPN port could be plugged to
Yep, if it's,
output data.
yeah, if that's plugged right in, if you plug that directly into your network, it'll pick up a DHCP lease.
Right.
And you run the program, it will automatically, well, have to know what the computer's
Yeah.
IP or
Yeah.
what the winch's IP address is, and then it will talk to it. And it's also possible to write your own program to talk to it as well. Depending on this, we did have one scientist that did that used my string and they wrote their own program to access it.
Might have been you that emailed me, but we had a winch in Alaska. And you probably noticed that the max tension values were like
Crazy.
20,000 pounds.
Yeah,
they're
And
crazy.
the broken 10,000 pounds before
Right.
that number.
Yeah. Yeah, we
So sorry if that made your processing.
we pulled out we found that there was a problem with the load pin.
Yeah, I could tell because it's telling me 10,000 with a slack cable.
Yeah. I didn't really see that at first and I sent it to Rick and then I started looking through the file. I'm like, Rick, I don't think some of these values are right.
That was fun.
I think some of our LCI 90s, and this chips, which is not the portable ones, but if we key a radio near them, it makes the tension increase a bit.
Wow.
Yeah. So, Bonnie actually changed cable, super cable. But it actually didn't make a difference. It's still going, so it might be something interesting to check. In home winches. Take a radio, because we always used to use squawk boxes and now they're migrated over to using radios. And the winch operator, but every time he would key the winch or key the radio, tension would spike up.
This was on the ship's equipment or one of the?
Yeah, no, the ship's equipment, yeah, not the portable ones, but the ships permanently installed.
We did have an issue with one recently where RF was causing a ground fault and sent an alarm and actually shut down the system.
Oh, no.
Right,
Yeah.
and yes, we've since discovered what caused that, and so far the short fix is the radio is farther away from the
Yeah,
electronics enclosure, but there needs to be a better fix.
We found that strange things as well. Put the radio like right on winch and wanted to talk to somebody, nobody could understand what they were saying. If they held the radio up 5 feet away from the thing, all of a sudden you could hear it loud and clear. But
What was this with our winch or, oh, I'll have to look at that.
The radios, the winch did not like to be close to each other.
I wonder if that,
Because there's an LCI 90i underneath it.
right. I wonder if some of that's due to and switching frequency. I'm just making stuff up.
Yeah.
So I don't make any. It is, I'm just thinking off the cuff.
In training.